Jubilant wishes to all. We are from RMD Engineering College, ECE Department. The mini project that we have chosen for the subject, EC8491 Communication Theory, is Amplitude Modulation. The team members are Subhashri KS, Varshni Sagarika MS, and Sophia B. Our team mentors are Dr. K. Helen Prabha, Ms. R. Aarti. Introduction. So, what is amplitude modulation? In amplitude modulation, the message signal is impressed on the amplitude of the carrier signal. This results in a signal whose amplitude is a function of the message signal. Forms of amplitude modulation. AM signals may be of various types, such as conventional double sideband AM, double sideband suppressed carrier AM, side, single sideband suppressed carrier AM, vestigial sideband AM. We have used multisim simulator that includes PSpice software for demonstrating amplitude modulation.
Here comes, according to the standard definition, the amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal, which means amplitude of the carrier signal containing no information varies as per the amplitude of the signal containing information at each instant. This can be well defined by the following figures. It can be observed that the positive and negative peaks of the carrier wave are interconnected with the imaginary line. This line helps recreating the exact shape of the modulating signal. This imaginary line on the carrier wave is called envelope. It is the same as that of the message signal. Time domain representation of the wave. Let the modulating signal be m of t equal to am cos 2 pi fmt and the carrier signal be c of t equal to ac cos 2 pi fct, where am and ac are the amplitude of the modulating signal and the carrier signal. Fm and Fc are the frequency of the modulating signal and the carrier signal. The equation of amplitude modulated wave will be S of t equal to AC plus AM cos 2 pi FMT cos 2 pi FCT. This is a circuit diagram, and this is an output wave forms in different scales.
Let us now look on to the advantages and disadvantages of amplitude modulation signal. Proceeding with the advantages first. It is simple to implement. Demodulation of AM signals can be done using simple circuits consisting of diodes. AM transistors are less complex. AM receivers are very cheap as no specialized components are needed. AM waves can travel a longer distance. AM waves have low bandwidth. Now, going on to the disadvantages. An amplitude modulation signal is not efficient in terms of its power usage. Power wastage takes place in DSPFC, that is, double sideband full carrier transmission. It is not efficient in terms of its use of bandwidth. It requires a bandwidth equal to twice that of highest audio frequency. In amplitude modulation sidebands contain the signal. The power in the sidebands is the only useful power. For 100% modulation, the power carried by AM waves is 33.3%. The power carried by an AM wave decreases with a decrease in the extent of modulation. AM detectors are sensitive to noise, hence an amplitude modulation signal is prone to high levels of noise. Reproduction is not high fidelity. For high fidelity, that is stereo transmission, bandwidth should be 40,000 Hz. To avoid interference, the actual bandwidth used by AM transmission is 10,000 Hz.
Now let us look at the applications. Broadcast telecom, broadcast transmissions. AM is still widely used for broadcasting on the long, short wavebands. It is simple to demodulate, and this means that radio receivers are capable of demodulating amplitude modulation, are cheap and simple to manufacture. Airband radio. VHF transmissions for many airborne applications still use AM, single sideband. Amplitude modulation in the form of single sideband is still used for HF radio links. Using a lower bandwidth and providing more effective use of the transmitted power, this form of modulation is used for many point to point HF links. Quadrature amplitude modulation. AM is widely used for the transmission of data in everything from short range wireless links such as Wi Fi to cellular telecommunications. Now, let us look at the demo of the simulation. The resistors R1 and R2 are used to form a voltage divider biasing. The capacitor C3 and the inductor L1 forms the tuned circuit. The AC source V1 is used as a carrier signal and V2 is used as a message or the baseband signal. We have set the message signal as 1 volt peak to peak and 1 kilohertz and the carrier signal as 2 volt peak to peak and 25 kilohertz. So it's clear that in amplitude modulation, the amplitude of the carrier signal changes according to the amplitude of the information signal. Thank you.